So, electrostatic actuation in principle is very simple. Charges with equal sign will repel each other. Charges of opposite sign will attract each other. So positive charges will repel each other. The negative charges will repel each other. A positive and a negative charge will attract each other. And most people have a feeling that they really understand this very well. And therefore, I have this little quiz question here. You see three scenarios, A, B, and C. And in each of the scenarios, you have two electrodes, a left one and a right one. These electrodes are, you can imagine them, they're in a huge space, small electrodes in a huge space, it's a vacuum, there's nothing around them, and they're kind of either freely suspended or freely hanging in that space. And the electrodes we put at a different electric potential. For example, in A we put the one at -5 volts and the other one at +5 volts. In B and C we have, of course, different voltages. So now the question is, for these three scenarios, the electrodes being at this potential and being put at the potential using a battery, for example, coupled to ground, will they attract each other, or will they repel each other, or will there be no force between these electrodes? So this is a seemingly easy easy question. However, I find that year after year students have great difficulty in answering this correctly. Let's have a look at the correct answers. Case A, the two electrodes will attract each other. In case B, there will be no force, and in case C, they will also attract each other. Intuitive mistake that many students make here is that they mix two concepts. They mix the concept of charge and the concept of electric potential, electrostatic potential. For example, case A, we know that electrostatic potential is -5 volts here and +5 volts here, but we do not know where are the charges. Is this positively charged or negatively charged? That you'll have to think of. I mean, if you in this case, for example, if you put this at +5 volts, the electrons will probably run from this electrode to this electrode. So one of the two will get positively charged and the other negatively. In this case, they're both at an equal potential. That means that the electrons that can freely move from the metal and to the ground to each other, they have no preference to be in one of the two positions, so they will be equally distributed between the two. So there will be no net charge. So if an electron, of course, would run away from here, it puts a negative charge here and a positive here, and you get a field. But because their potential is equal, they will distribute equally, and there will be no charge between the two. So though they are positive potential, the net charge is on each of them is 0. In this case, you have a different potential, and therefore the electrons will rearrange between the electrodes, and you'll get a positive or negative charge on one of them, and so you get an attraction. So what do we learn? Basically, if we put two electrodes at a different potential, they will always attract each other. If we put them at the same potential, there will be 0 force in between them. And we can think that because there is, for example, a different potential, will have an E field between them, and the E field will result in an attractive force. If they're at equal potential, there will be no E field between them, and there can